This is section 11.2. We're going to talk about permutations today. A permutation is an ordered arrangement of items that occurs when, this is important here, no item is used more than once and the order of the arrangement makes a difference. Make sure you memorize these two items. These are critically important when it comes to a permutation. When it says no item is used more than once, what we're usually talking about is people. Even if you're a twin, you're still talking about two distinct people. So when you have people involved, this is almost always a permutation. You're in charge of planning a concert tour with U2, NSYNC, Aerosmith, and the Rolling Stones. You decide that the Rolling Stones will perform last. How many different ways can you put together the concert? So you have 1, 2, 3, 4 groups that are playing. So you have 1, 2, 3, 4. This is who plays first, who plays second, who plays third, and who plays fourth. Now you did decide that the Rolling Stones have to perform last. So Rolling Stones, there's only one way to put the Rolling Stones last, so that's one choice. Now we have 3 different bands that we haven't used yet. We've got U2, NSYNC, and Aerosmith, and any one of those 3 could go first. For second, you've already used one band. We don't know which one it is. It could have been U2, could have been Aerosmith, but we've already used a band. So that leaves 2 bands that we don't know, that we haven't used yet, that could go second, and there's only one band left. So the number of ways that you could do a lineup is 3 times 2 times 1 times 1, or 6 different ways. When we have something like 7 times 6 times 5 times 4 times 3 times 2 times 1, a shortcut way of saying that or writing that is factorial. We put an exclamation point and it's read factorial. In math, the exclamation point is factorial. The definition, if I have 0 factorial, that is not 0. 0 factorial is not 0. In math, 0 factorial is 1. Something you just need to remember. Evaluate without a calculator. In this, what they want you to do, if you have 8 factorial, you know that that's the same as 8 times 7 times 6 times 5, 4, 3, 2, 1. And on the bottom, we have 5 factorial, 3, 2, 1. Well, what they want you to do here is cancel. If the number's on the top and the number's on the bottom, you're going to cancel it out. So 1 goes into 1 once, 2, 3, 4, and 5. So what's left is 8 times 7 times 6. Now for this part of it, you can indeed use a calculator. That's not what they're talking about. What they don't want you to do on a calculator is 8 factorial, punch that into your calculator, divided by 5 factorial. As far as finding the factorial button on your calculator goes, ask me in class and I will show you on your calculator where to find the factorial button. So you would actually multiply those out, and offhand I don't know what that is, but we can see on the next slide. What is it? It is 336. 336. Now for the next one, we have 26 factorial, and I would really prefer not to write all 26 numbers out. If you notice this one right here, notice I knew that I'm going to have 5 factorial on the bottom. And 5 times 4 times 3 times 2 times 1, that's 5 factorial. So in fact, I have 5 factorial here, and I have 5 factorial here. So what I could have done instead, I'm going to erase this, is written 8 times 7 times 6 times 5 factorial, because I know I have a 5 factorial on the bottom. Now notice that's not 5, it's 5 factorial. I can cancel 5 factorial and I have a lot less writing. So in the same way, we're going to do the 26 factorial. So I can do 26, 25, 24, 23, 22, and with the 21, I'm going to write it as 21 factorial because I know that I have a 21 factorial on the bottom. So those 21 factorials will cancel, and so now I'm left with 26 times 25, 24, 23, and 22, which is 7,893,600. There is a formula for permutations. This is the formula for permutations which you can use, although usually it's just as easy not to use the formula because this is just one more formula you have to memorize. You and 19 of your friends, be careful here, that means you have a group of 20, need to choose 3 officers. The 3 officers are called a CEO, an operating manager, and a treasurer. And how many ways can those offices be filled? So if this is the CEO, and this is the manager, and this is the treasurer, so let's suppose we choose the CEO first. How many options do we have? How many choices do we have for the CEO? Remember, we have a group of 20. Once somebody is already chosen as the CEO, how many choices now do we have for the manager? Well, somebody's already been chosen, so now we only have 19 people that could possibly be the operating manager. You can't have a duplicate here. You can't repeat. You can't be both a CEO and an operating manager. Once we've chosen a CEO and a manager, we've used 2 people for those offices, and now we're down to 18 choices for the treasurer. Multiply those together, 6,840 different ways we could choose 3 officers. By the way, this does give you the formula if you would choose to do it that way instead. When we have duplicate items, this one formula you do need, you're going to have n factorial over, these are the repeats. This will make a lot more sense once we actually get an example. The thing to remember with this formula is it's always about words that have repeated letters. For example, if you have the word Mississippi, how many ways can the letters be arranged? First thing you're going to do is count the number of letters total. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So we have 11 factorial on the top. Now we look for repeated letters. Does the M repeat? No, so we don't have to worry about it. Does the letter I repeat? Yes, it does. How many are there? There are 4 I's, so we put a 4 factorial in the bottom. Now we look at the S's. There are 4 S's, so we need a 4 factorial. We have the letter P. We've got 2 of those, so we need a 2 factorial. Now we simplify it. Now I know you're wanting to cancel the 4 factorial with something from the 11 factorial, and you're right, but we can only cancel one of the factorials on the bottom. We can't cancel all 3 with the 11 factorial, so you have to pick one. Usually you pick the factorial that's the largest. So let's suppose we will cancel with the top this 4 factorial. That means that these 2 have to be written out as 4 times 3 times 2 times 1. times 2 times 1. So the 11 factorial, 11, 10, 9, 8, 7, 6, 5, 4 factorial. This 4 factorial we're going to leave as 4 factorial so that it cancels with that one. But these two, you're not allowed to cancel as a factorial. So this 4 factorial, I know it's getting kind of rough in here, but that 4 factorial you have to write as 4, 3, 2, 1, and this 2 factorial as 2, 1. Now, when you're simplifying, guys, as long as the number goes in evenly, you can cancel. So for example, I know that 4 goes into 8 twice. I know that 2 goes into 2 once. I know that 3 goes into 6 twice. And I know that 2 goes into 2 once. Now, everything on the bottom is canceled. We don't need to worry about the ones. So what does that leave us on the top? On the top, we still have the 11, the 10, the 9. We don't have the 8 anymore, so I'm going to erase that. We have the 7. We canceled the 6. And we have the 5. So we're going to multiply those numbers together. And 34,650. Your homework is 4 through 52, every 4.